Good morning, everybody. My name is Oluitan Akisenyiwa, and I will be the teacher that will be taking you JAMB lesson as far as this session is concerned. Now, today we are going to treat a subject called mathematics. Now, in mathematics today, the topic that we are going to cover is a set theory. The first thing we deal with is the definition. Later, we talk about the types of sets. Later, we talk about the operations. And after the operations, we are going to talk about the operations involve the union and the intersection. Then we are also going to talk about the complement of a set. Now, in this case, another one here, we are going to deal with Venn diagram. I think those are the subtopics that we are going to cover, that JAMB recommended us to cover as far as a set theory is concerned. Now, let's quickly start. Now, what do you mean by a set? A set is just a collection of items. It's a collection of items of the same characteristics. Say, for example, now, you can say that a set, a set is a collection of items of the same characteristics. Now, what they are telling us here is that by the time we combine some things, take for example, maybe we are dealing with a particular class, SS2 class of Kunike International School. Now, that class consists of a lot of students. Now, the collection of that students in the class is known as the set. Now, each items inside that set is known as element. Each items inside that set is known as element. So if I want to say that in Kunike SS2, the students that are there, each of the students are elements in that SS2 because they belong to SS2. So every members, every items in a particular set is known as element. Take for example now, another example is maybe list of fruits. If I'm talking of list of fruits, then that means mango is an element, orange is an element, cashew is an element, and the like. So all those members that belongs to a certain group is known as a set. It's known as a element, sorry. Now that's just the definition. Now we can represent it. We have so many types of sets. Now the types of sets are types. The first one is finite set. Finite set. Finite set is a kind of a set that has limitation, that you know the beginning and you know the end of that set. For example now, if they say that list of even numbers from 1 to 20, that means we are going to start with 2, 4, 6, 8, 10, 12, 16 or 14, 16, 18 and 20. So that one, it has a boundary. Any set that is having a boundary, that has its own limitation, is known as a finite set. Now another one is an infinite set. Infinite set is a kind of set that that does not have a limitation. Take for example now, list of whole numbers. When they say list of whole numbers, numbers don't end. That means we are going to be listing all number and we don't know when it's going to end. A kind of set that consists of element that does not end is known as infinite set. Then another one is subset. Subset. When we have a subset, it involves two sets. One is now a characteristics of one now contain what the other contains. Take for example now, in a class of maybe in a number in from number 1 to 20. Maybe let's assume that we have a set of numbers from 1 to 20. Integers, no, whole numbers from, let me just say integers, I think that one is better. Integers from 1 to 20. Now, if I want to pick a subset there, maybe I now say A. A consists of even numbers from 1 to 20. This A is a subset of this mu that I have there, because there is no way we can be talking of numbers of 1 to 20 that will not see even number there. So that anything that this A now is a subset of this. So if I want to represent, that is the one that we usually use to represent subset, I will say A is a subset of mu. That is, this A is a subset of mu. So that's the symbol that is used to represent. That is, what mu contains, A contains some of it, even all of it. So in as much as it contains all of it or some of it, then it's also a subset. Now let's quickly move to the next type. The next type of set that I want us to know is empty set. A set is said to be empty when there is nothing in the set, when it has nothing in the set, when there is nothing in the set, and it's usually represented as this symbol. Or, now mark you, every set that we are listing as far as mathematics is concerned will always be denoted by these curly braces. As we move on, we are going to be working with different types of sets. Now let's quickly talk about the last one that I think, though there are many, but let me just stop here. Disjoint set. Disjoint set occurs between two sets. When two sets does not have anything in common, then they are disjoint. They are disjoint. Maybe what is in the first set is not in what is in the second set. So they don't have anything in common. So they are that when two sets does not have anything in common, you can call them disjoint set. So that is that. Now let's quickly go to the operations on set. Union and intersection. Example. Now, let's look at this now. We want to use this question to to perform some operation. Now, when we are talking of union of a set, union and intersection, let's quickly define that. When we are talking of union of a set is just a combination of everything that is inside two sets. When they are saying union, that is joining together. So the combination of what you have in one set to the other. Now when they say intersection, intersection is what the two sets have in common, what they have in common. And the union of sets, when they are talking of union, union is usually represented as this symbol, whereas intersection is represented with this symbol. Now let's quickly work on the exercise that I put on the board. They say that if this mu, which is usually known as universal, is the numbers from 1 to 20, and this is A is even numbers from 1 to 20, B is multiples of 3 from 1 to 20. It is clear to do. We can easily solve this kind of question. It's very simple to do. The first thing we do is that we say A, and you now say that find A union B, find the A intersection B. Now what can we just do here? The only thing we need to do here is that we are going to bring out we are going to expand the items that we just write in this format. We are going to expand it. And how do I expand it? It is easy for me to do. I can easily expand this one now by saying, okay, let me expand this. This one will be 1, 2, 3, 4, 5, up to 20. This one, I can easily expand it. It's a finite set. This one is 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now this one, multiples of 3. This one is also easy to expand. I can see all the multiples of 3. We have 3, 6, 9, 12, 15, 18, and nothing. So this one ends at 18 because the next multiple will be 21. So let's continue. A union B will now be what? If I want to do this A union B, I will combine what I have in A with what I have in B because they say union. I will combine the two together. But the rule is that you must not repeat any number twice. You must not repeat it twice. Any number you pick, you must just pick it once and for all. Don't say because one number is in A and the other number is in B and you now write the two together. Once you have written one, it's enough. Now let's quickly write A union B. A union B will now be what? 2, 3, 4, 6, 9, 10, 12, 14, 15, 16, 18, and 20. Now another rule is that you must always write in ascending order. Always write in ascending order. As they have already arranged it, write it in ascending order. It may not be numbers anytime. Sometimes it may not be number. Sometimes it may be any other thing. But just follow this pattern and you are going to get it. Now how do you do A intersection? A intersection B. A intersection B can be done in this way. What do we have in common? We have a 6, we have 12, and we have 18. So those are the things that we have in common. So that's the A intersection B. So that is that. The next one is that's how to go about the union and the intersection. The next one that we are going to talk about now is the complement of a set. Now complement. When we are talking of complement of a set, then it is usually represented by in form of a prime like this. Say for example, what do you mean by complement sef? Complement is just anything that is in universal set that is not in that set. For example, let's take this one now. Let universal set be equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then let our A be 2, 4, 6, 8, and 10. And let our B maybe our B is maybe 1, maybe 5, 10, 15, and 20. Now this is a universal set. Universal set is just what encompasses a whole set of number. Do you get that? A whole set of number. So just like one now make use of the SS2 class of Finite International School. The SS2 class itself is a universal set. There are so many things in that class. Part of the things that are in that class are the chairs and tables. So those ones are some elements there. It's another element. In that class, there are male students. It's an element. Those one male students are elements too. Another set inside it because no, the the chairs and table in the class are some subsets in the class. The male students that are there are another set inside that set, which is the class. The female students that are there are also another set another set inside that set. Now all those boys, maybe Taiwo, Tope, and all these what have you, that are the students there, they are the elements. Now when we are now having a particular set inside a particular set that is encompassing them, the one that encompasses them is known as the universal set. So this one is the universal set. It's the one that take care of all other sets within. Just like I told you about the SS2, we have the another set inside the SS2, which are the boys, the girls, the chairs and tables like that. So many things are under inside that SS2. Those things are complement and are another set, and each side of this set there are some elements there. So when we are talking of the chairs and table, it's a set on its own. Is there. Then we also have the girls. Maybe you are talking of a Cynthia, Tayo and the likes. Those ones that are mentioning their names, they are the elements inside. So all this U, A is a set under U, B is a set under U, and it consists of elements. And all these elements are inside the universal set because it's the one that covers everything that those sets contain. So let's continue this. So this is now if I want to talk about A complement, this symbol is used to represent A complement. And how do I go about this? I will say that A complement means what is in the universal set that is not in A. The thing that is inside universal set that is not in A. Now how do I go about A complement? A complement now will be A complement will now be 1, 2 is there, so we are not writing it. 3, 4 is there, we are not writing it. 5, 6 is there, 7 is not there, 8 is there, 9 is not there. So that's A complement. Then when we are talking of B complement, B complement can be B complement. How do I go about this? B complement is what we have inside the universal set that is not in B, and that will be 1, 2, 3, 4, 6, 7, 8, and 9. So sorry, I've already corrected myself there. So that's it. Now the next one that we are going to be dealing with is the complement, the Venn diagram. Venn diagram is a kind of mathematical tool that used to solve some problems in mathematics, especially when it comes to set related problems. But we need to deal with many things. But before we go into that Venn diagram, let me see whether we can perform some operations here. Now let's assume you have A union B complement. Now we all know what is in A, and we all know what is union B when in B complement. You can union them together. And how do you do that? You can say that 1, everything will now be 1, 2, 3, 4, 6, 7, 8, 9, and 10. So those are the things that we are going to union there. Now another one, maybe if you have maybe A complement intersection B complement. Now let's see whether we can have A complement intersection B complement. That is what A complement and B complement has in common. Let's see whether we can get something there. So that's 1, So those are the small operation that we can be doing in that as far as complement is concerned. You can always try that one, and you see that it is very simple to handle. Now let's go to Venn diagram. Now we can do so many things on Venn diagram. We use it to represent many informations, like I said earlier. Now if I want to write Venn diagram, I can say that Venn diagram is just like this. This is how a Venn diagram look like. It consists of two things like this. It can be two elements, two sets, and this one will now be the universal set. Everything that is inside that here is the universal set, whereas these circles are the is also another set inside that universal set. So it's like a subset. So this one is a subset to it. Now we can play with some Venn diagrams. Now maybe this is set A and this is set B. Now we can do so many things with our Venn diagram. Let's freestyle to some extent. Now let's talk about I can represent many things with Venn diagram. If I talk about this one, this is set A, this is set B, and the whole thing here is the universal set. So if I shade this one, this means A union B. What I've shaded is A union B, that is everything in A and everything in B put together. Are we there? So that's how A union B looks like. Now I can do like this too. I can say A and B. This A, B. I shade this place. This one is A intersection B. A intersection B, meaning that what A and B have in common. This is what A and B have in common. If you look at A is going like this, B is going like this. This is the place where they meet, and that's what they have in common. So that's A intersection B. I think that one justifies the definition we gave it earlier. Now let's quickly go to another one. Another one is maybe this is A and this is B. So that means A is a subset of B. So this A now is a subset of B, because it's inside this B that you have your A. Now let's take another one. Maybe A, let me take this one. Maybe let me draw A complement. A complement. So if you want to say complement, we say complement. A complement. How do I go about it? What is inside the universal set that is not in A? So if I want to get A complement now, I will shade everywhere in the universal set. I shade everywhere. But I will leave A alone. I will leave A alone. I will leave A alone and shade everyone that is there. So this place now is A complement. So there are so many ones that I like that. If you want more of it, I can always explain that one further. So there are so many ones. So like this one now, if you have A complement intersection B, let's look at this. We firstly take care of the A complement. What's the A complement now? I think I've talked about A complement before. So this is A complement intersection B. Intersection B is that all these A complements, where does B is where is B common with it? Where is this A complement? The place where I've shaded. Now, which place is it sharing in common with B? That means I will have to erase this, erase all the shadings here, erase the shadings, erase it, erase it, erase it. So this is a place where the complement is sharing in common with B. So that is that's it. So this is a complement. I can say complement union B. A complement union B. That is, I also draw my A complement. Everything shaded apart from A. So this one is the A complement now. Now, where is this A complement? I will now union it with B. So all the place that B is covering, I'll shade it with it. So this one is A complement union B. I think that one is clear enough. Now let's see whether we can solve some questions on Venn diagram, maybe one or two, and let's see how we can handle the situation with ourselves. So look at the question. Yes. Look at this question. They say that in a class of 550 students, 290 take French, 220 take Latin, while 80 do not take any of the two languages. Find the numbers of students who takes both French and Latin. It is easy to analyze on a Venn diagram. Now let's see how we are going to go about it. Firstly, draw our box. Since we have two things there, because it is in a class, so this one represents the class, and the whole student, which is the universal set, is 550. So everybody in that class is 550. So let me extend it. 550, let me extend. 550. Now, you take both French and Latin. So the one that is here, let F be for French and let L be for Latin. Now, they say that 290 take French. Now, there is one thing about this life. We have to be very technical about what we usually hear in our question. Now, they say 290 take French. They never said French only. There could be out of those 290 that they mentioned that are stylishly taking Latin. Now, they say that 220 take Latin. They never said Latin only. Some people among those people that are taking that Latin may also be taking French that we don't know. But they just say that one is 290 take French, 220 take Latin. So that one is not clear enough. We cannot just put 290 in this place that is French. We cannot just put 220 in this place that is Latin. We need to first say that let X be for people or students who take French and Latin. So that means I'm going to put that X right here, because that X represents those people that are taking French and Latin. That's why you have it in common. They are in common. They take both French and Latin. Now, this one, if I want to represent this one now, the one that is taking French, I will write it. But I will need to give account of those people that are among those people that are taking the French and as well taking the Latin. So that means they will belong to this X category. I will remove this minus X. Now, another one is 220 take Latin. I will have to write this 220 again and remove those people that are stylishly taking French out of them. So those people will now belong to those people that are taking French and Latin and French together, which is also the same thing as this X. Now we can now solve this. They now say that 80 do not take any of the language. They don't belong to the language takers. So those people will be outside the set because they don't belong to the group. They don't take anything there. So that one, you leave them in their place there. Now let's quickly solve this problem now. All we need to do is that everything here, these people will now be, this 290 minus X will now be people that are taking French only. This place will now be for those people that are taking French and Latin, and this place will be for those who that are taking Latin only. This place will be for the person that does not take anything. So it is believed that all these people are member of that class, and that means all of them will add up to be equal to 550. Now let's quickly go about this. So all of them will add up to 550, and let's go. So that will be 290. Mm-hmm. Are we there? So we can now say that 290, 510, 590. So will be 590. So will now be minus x equals to 550. So that means minus x equals to 550 minus 590. And that will be what? Minus x equals to minus 40. X will now be equals to 40. So therefore, 40 students take both French and Latin. So 40 students take both French and Latin. Now let's quickly check what we have just given account of. So if 40 students is taking both French and Latin, that means I want to represent the information now. So the French only will now be what? 290 minus x, which is equal to 290 minus 40, and that's what 250. The Latin only will now be what? 220 minus 40, which is equal to 180. Now the both languages will be 40, and none of the language, none will now be what? 80. Now if we add everything together, we are still going to get our 550. 8 people does not take, that's 80, plus both, that's 120, plus this one, that's plus this 180, that's 300, plus this, that's 550. So I think you have found the videos on set theory so helpful. If yes, kindly subscribe to our channel, like our video, and make comments. Thank you so much. God bless you.